Okay guys, don't forget to put this assignment on the Google Class, both sides. Make sure that your name is on the paper, okay? I'm going to go ahead and help you out with some of these. And I think we did this one yesterday. So let's do number 3 together, okay? Lithium. You're going to tell me how many valence electrons it has. So what's your Lewis dot structure? Lithium is in the alkali group. It's in the first group. So you have 1 dot. Sulfur is in the oxygen family, and you have 6 valence electrons. So you have 1, 2, 3, 4, 5. Let's put 6 over here. Now remember, you're going to tell me, is this an ionic bond or a covalent bond? Because lithium is a metal and sulfur is a non-metal. This is an ionic bond. So because it's an ionic bond, you're going to transfer your electrons. So you're going to have lithium transfer is going to give away to sulfur. So now lithium's happy because it's lost all of its valence electrons. And sulfur now has 7 valence electrons, and it's a little closer to being in that happy state. Remember, the happy state is every single element can have up to 8 dots to be stable. Okay, so it needs 1 more. So that means you're going to add another lithium. Of course, you're going to draw this where you're going to have more space on your paper. And lithium has a dot. It's still an ionic bond. So you're going to have a bond here because you're going to transfer that electron to that empty space. And now sulfur has all 8, and lithium gave away all of its dots. So remember, one's going to be the giver and the other one's going to be the taker. Okay, let's move to something that maybe we didn't do yesterday. Remember, you're going to use yesterday's notes to help you out with these, okay? All right, beryllium has 2 dots. It has 2 valence electrons. And sulfur, as we said above, has 6. 1, 2, 3, 4, 5, 6. Now notice that I put those electrons on this side. That way you have an empty space here and an empty space here to do your bonding. Okay, so now beryllium, is it a metal or is it a non-metal? It's still a metal. And sulfur, is it a metal or is it a non-metal? It's still a non-metal. Okay, so what you're going to do here, you have an ionic bond, so do they share or do they transfer? It's going to transfer. Okay, so this dot is going to transfer to sulfur. Because sulfur already has 6, it's easier for it to pick up only 2. Beryllium only has 2. It's going to be easier to transfer those 2 and lose 2 electrons than try to gain 6 electrons from someone else. Okay, so sulfur now has 7 electrons. Beryllium still has 1 to give away. So it's going to take this dot and it's going to take that empty space. And now all of berylliums are given away or transferred. And sulfur has all 8. And so that's it. Okay. Well, here's a good one. Number 6. Everybody usually has trouble with that one. Okay, and that's just because it's a little long. It's not hard. So magnesium, how many valence electrons do you have? And I'm pretty sure you guys told me too, because I know you guys are smart. You can get this. Okay, nitrogen is going to have 5 valence electrons. So we're going to have 1, 2, 3, 4, 5. Now it has an empty space here, an empty space there, and an empty space here. So now, magnesium, is it a metal or is it a non-metal? It's a metal. Nitrogen is a non-metal. So you're going to transfer electrons, right? So this valence electron is going to go to this empty space, and this valence electron is going to go to this empty space. Is magnesium happy? Yes, because it gave away its 2 dots. Now, is nitrogen happy? Maybe not, because there's still an empty space. It only has 7 dots, right? So we're going to add another magnesium with 2 valence electrons. Whoops, there we go. Let's do that again. Okay, here it is. And so this empty space is going to be taken by this dot. And here we go. We have our transfer. So now, does nitrogen have all 8? Yes. So nitrogen's done. Okay, but now magnesium has a valence electron left. All right. So we need to add another nitrogen. Nitrogen has 1, 2, 3, 4, 5 valence electrons. Okay, so let's have an empty space here, an empty space here, and an empty space here. Okay, this valence electron can transfer to that empty space. Magnesium no longer has valence electrons, so it's satisfied. But is nitrogen satisfied? It has 2 empty spaces, one here and one here. So that means we're going to need another magnesium. It has 2 valence electrons. This valence electron is going to go to this empty space, and this valence electron is going to go to this empty space. You see how you keep going until everything's a filled shell? So nitrogen has all 8, so it's happy, and magnesium has given away its 2. Remember, one's the giver, one's going to be the taker. So this means it took 3 magnesiums and 2 nitrogens to make this bond. Okay? And that's it for that page. All right, so go ahead and try to do the rest of the ones here on this page. Make sure you look at the notes to do the rest. Okay? Let's go back. Carbon and fluorine. Carbon has 4 dots. 1, 2, 3, 4. Fluorine has 7 dots. 1, 2, 3, 4, 5, 6, 7. So it's got only 1 empty space. Now, carbon, is that a metal or is it a non-metal? It's a non-metal. Fluorine, is that a metal or a non-metal? It's also a non-metal. So when you have 2 non-metals together, what type of bond is that? Yep, it's a covalent bond. So that means they're going to share. That means that this electron's going to share with this electron, and we're going to bond right here. Okay, can fluorine take any more valence electrons? Nope, it's got all 8, so it's done. So what are we going to do here? Well, we can add another fluorine. Let's move that down a little bit. Up here, that has also 7 dots, because it will always have a valence of 7. And it's a covalent bond still, so it's going to share right there. Is fluorine happy? Yes, it has all 8. Has carbon given away all of its electron dots? Nope. So we need to add another fluorine. Here's 1, 2, 3, 4, 5, 6, 7. So we're going to have a sharing of electrons right there. And now carbon has another valence electron that it wants to share. So we're going to put another fluorine over here. And now we have this bond here. So it took four fluorines to bond with one carbon. This is a covalent bond. Okay. What about when you have something that has the same? Okay, let's do something like, whoops, let's move that up. Like sulfur and oxygen, like number 11. Sulfur has 6 valence electrons, and oxygen also has 6 valence electrons. So how are you going to do that? Well, sulfur is actually going to be in the middle. You have 1, 2, 3, 4, 5. Let's do 6 over here. Okay, the truth is that sulfur is going to share all of its 6 with oxygen. Okay, so oxygen is always special. You're going to have 1, 2, 3, 4, 5, and 6. Or you know what, let's do this on this side. Okay, and so you're going to have, because it's a covalent bond, you're going to have these 2 valence electrons share, and you're going to have these 2 valence electrons share. Now, what is this called? This is actually a double bond. Okay. And then you're going to have another oxygen on this side. 1, 2, 3, 4, 5, 6. And again, it's a covalent bond, so these are going to share, and then these are going to share. Okay, so we still have 2 valence electrons left over, so we're going to add another oxygen. And you have 1, 2, 3, 4, 5, 6. So these 2 will share, and these 2 will share. I know this is the one that most people have trouble with, so I hope that helped you out in case we had any questions on that one. Okay, magnesium is going to be another long one, just like the one that we did a little earlier. Little helpful hint, you're going to have 3 magnesiums for every 2 phosphorus to actually make that complete. Don't forget to do the drawing. Okay, you still need to do that. Now, what happens when you have a charge, like here in number 15? Okay, when you have a charge, that's telling you exactly how many valence electrons it has. So let's go ahead and do that one. Zinc has a +2, so you have 1, 2 valence electrons. Whoops, there we go. Okay, bromine has 7 Lewis dots. It's got a valence number of 7. Okay. So, now is this a ionic bond, covalent bond, metallic bond? What type of bond is this? Zinc is a metal, it's a transitional metal, and bromine is a nonmetal. So it's an ionic bond. So what do we do with an ionic bond? Does it share or does it transfer? It transfers. So you have an empty space here. This valence electron is going to transfer to that spot. Now, does bromine have all 8? Yes. But remember, if bromine has all 8, that means zinc has to give away all of its dots. Is zinc happy? No. So we need to put another bromine. And you have 1, 2, 3, 4, 5, 6, 7. We're going to put it over here just so it can be clear. Remember, always make your drawings clear to make it clear on what it is you're doing. Okay, so there's an empty space right here. This dot is going to transfer to that empty space. So now, has zinc given away all of its dots? Yes. Does bromine have all 8? Yes. So you're done. There you go. Okay, go ahead and do the rest. Don't forget to put your name on it. Take a picture of both sides. Turn it into Google Classroom. The due date is by today.